Welcome to Blue Glasses Math. In this podcast, we will explore how our self-perception as math teachers and learners influences our approach to life. Whether you identify as a math enthusiast or not, this podcast is for you. Are you a teacher, a parent, a school administrator, or a student? Join me as we shift our perspective on what it means to be a math person. Let's take a look. Welcome back. And today's episode is a solo episode. I'm super excited to have this time with you. I haven't had time to connect with you in a really long time, so today is the day. I want to talk today about something that doesn't normally show up in district PD, but I think we're starting to pay a little bit more attention to it. And that is the emotional landscape that happens in a math class. I've been doing professional learning. I've been facilitating professional learning for a really long time, probably about 15-ish years. And when I first started providing professional development to teachers, the number one thing that was at the top of the list of what teachers wanted is they wanted to walk away with a handout, right? Something that they could take back to their class and implement right away. Now, this is before teachers pay teachers, before, for sure, AI, where you could just generate a worksheet. But this is what teachers wanted. They wanted something that they could take back to their classroom to do right away with their students. And I don't think that's changed too much, right? Because even now when I give professional learning workshops, I always provide a Google folder with a bunch of things that they can do, the teachers can take back to their classroom that they can implement right away. But I've started creating more opportunities for teachers to co-create in that space where I share a Google folder. The folder is open so that teachers can go ahead and share with one another within that folder based on the context of whatever that workshop is. And the reason why I'm starting here is because I do know that in math class, we need to have things. We need to have things for students to do. We need to have activities for them to participate in. We need to have things that are going to move the curriculum forward and give students the opportunity to engage in curricular work. 100%. But there's this other layer that I think often goes ignored. And I don't think it's because teachers don't want to pay attention to this. I think it's just because we haven't given opportunities for this to be discussed. And that is emotions. Emotions in math class. Every student and every teacher, because they're human, come to the classroom with a huge portfolio of emotions, and they bring them to math class. And those emotions about math and about themselves as mathematical learners or mathematical teachers are all based on the narrative, the stories, the things that have happened to them over their school year or their previous school years, messages they're getting from home, from the community, from their friends. And at the end of the day, emotions really make a big difference, no matter what teachers pay teachers, no matter what worksheet you're handing out, no matter what activity or thinking task you have set up in your classroom, there's always going to be this suite of emotions that comes along with every single student in the classroom. And those emotions will also contribute to students' development of their beliefs. Do I believe that I'm smart enough to be in this class? Do I believe that I can work in a group at a non-permanent vertical space and work with another student? If you don't know what a non-permanent vertical space is, you need to check out Peter Liljedahl's work on building thinking classrooms. But when we create conditions in math class, we try really hard, of course, to be inclusive and to give everybody a chance to participate. However, what sometimes I think we forget to think about is how are these experiences that students are having informing their beliefs through their emotions. So let me back up here for a second. I'll tell you a quick story. So here's a story about a class I was just recently in. It was 5th grade. They were learning how to multiply decimals for the very first time. Now, these students I think they had done multiplication of fractions, and I know they had worked on the area model for whole numbers at this point in the year. So they understood multiplying multi-digit numbers, but this is different. Right? Because when we're multiplying decimals, something weird happens. What's the weird thing that happens? Yeah. So hopefully you are already thinking about the weird thing that happens when we multiply decimals for the very first time. Unless the students had been multiplying fractions earlier in the year, the product, the answer to the problem, becomes sometimes smaller than the two factors, or at least one of the factors that you're multiplying, which is the very first time that this happens in multiplication. So up until now, students are multiplying numbers like 3 times 8 or 14 times 30, and every single time the product comes out to be a bigger number than the two numbers that they started with, right? Now all of a sudden, things are different. So let's take, for example, 3 times 5/10. 3 times 5/10. Okay, so and I'm thinking about 5/10 as 0.5. But I don't like to say it 0.5. I say it 5/10. Proper place value language, attending to precision. Anyway, if we do 3 times 5/10, what happens is we end up with an answer that is smaller than one of the factors. It's smaller than 3, so we end up with 3 times 5/10. We get 1.5, 1 and 5/10, however you want to slice and dice it. And off the bat, the first thing that I see many teachers doing, and I totally get why they're doing this. I totally do. They look in the book and they say, oh, there's all these models, these pictures, right, of like multiplying using, usually it's a base 10 block, right? So picture a square and picture that square broken into 10 vertical equivalent sections. So that one square represents one whole, and each of the vertical sections represents 1/10. Okay? Now, getting back to, we're multiplying 3 times 5/10. So 3 times 5/10 would be 5/10 and another 5/10 and another 5/10. So as students start maybe shading in that square, right, shading in 5/10, they start to realize, oh, well, I'm going to need 3 of these things. So automatically my answer is going to be bigger than 1, but it's going to be smaller than 3. And from there, students can go ahead and do the thing and start to realize, oh, wait a minute, 3 times 5/10 that has the same numbers as 3 times 5, the 1 and the 5 for 15, but then where does the decimal point go? Using the idea of the base 10 blocks where they've shaded in, they start to really understand quickly how to place the decimal point. Now, I was taught that you just multiply the 3 and the 5, make it easy, 1, 5, and then move the decimal point, swoop it in, right? Or I don't know, different teachers use different techniques where you like move the decimal point. But the problem is decimal points do not move. Does that surprise you? Decimal points do not move. The decimal point stays in the same. It is a stake in the ground. The numbers move around the decimal point based on the value that they have. But what happens often in classrooms is when I see teachers look at that and they say, oh, you know what? This is just way too much discussion. We're just going to teach them the rule. They're going to multiply the numbers and we're going to move on. Now, while that may make everybody in the room feel really comfortable, right? Because they're like, okay, straightforward, quick and dirty. Let's get it done. I can do 100 of these. I'm getting them all right. Great. But when you ask a student then to estimate or to make an approximation of a decimal multiplication problem, they have a really hard time doing that. And then that's when they start to think, okay, well, now I can't, right? And the other thing that I've been trying to communicate with teachers, and I'm so curious to know what your thoughts are on this, but we as humans have 3 basic psychological needs. They are autonomy, competence, and relatedness. Okay, so I won't unpack each one of those, but let's just talk about autonomy. So these are basic psychological needs in order to be like motivated to do whatever the thing is we're trying to get somebody to do. So think about your teenage kids or your 3-year-old nephew or whoever is trying to learn how to do something like ride a bike, ski down a hill, drive a car. In order for them to feel psychologically comfortable with that, they need to have some autonomy, right? So when a student learns, when a high schooler learns how to drive a car, of course they're terrified at first, but they need the autonomy behind the wheel in order to develop that confidence and also knowing that the teacher who's sitting in the passenger seat, bless their heart, is feeling safe enough to hand over the physical car for the student to do the driving. Yeah. And in math class, what often happens is we hear students say, I don't get this. And then we as teachers have so much to cover. We're like, here, just do it this way. Just follow these steps. But in that, we are not giving students an opportunity to think and reason and be autonomous. Yeah. And I get it. I mean, especially in schools that I've worked with where the pacing calendar is like the top of the list of the priorities, or there's quarterly assessments. And trust me, I have sat in the seat of the quarterly assessment teacher for the very first time when quarterly assessments started coming out. I was like, it was horrible. Those weeks when, in those days, quarterly assessments were not on computer. They were paper and pencil and took 3 days to correct or to mark. And so I get it. I know the fidelity to the curriculum, all of these things. The teachers, like, it's all this noise, right? All this noise. But at the very end of the day, when we focus on all of those things, and I'm talking to teachers and leaders now, when we focus on benchmark testing and quarterly assessments and fidelity to curriculum and all of these things, while they may be important in their own merit, something gets lost in here. And the thing that gets lost are the kiddos, the students, the very reason, our clients, the very reason why we are doing what we're doing in schools, because we're like, here, just do it this way. Here's a quick method to do it. Here, look at this anchor chart. Here, follow this procedure. And then we wonder at the end of the day why students don't like math. We wonder why the kids who enjoy math or feel happy in math class are the ones that everybody knows, well, you're happy in math class because you get it. And I was in a classroom last year where a student said that math is an emotional subject, and there's a whole story behind it, but math is an emotional subject. And I'm like, really? Tell me more. And this is the very first time I was meeting these students. I was meeting these students for the very first time. Came in as a coach. I told them my name was Dr. Brett. They immediately started trying to figure out what type of doctor I was. One student said, "Are you an emotional math doctor?" And I said, yeah, that's exactly what I am, because I've spent the better part of my career thinking about how emotions weave themselves into math class, or where they show up in math class. And this student nailed it. So then, of course, I had to ask him, well, what do you mean, emotions in math class? How could I be a psychological math doctor? So then we had this whole conversation about what does it mean to have emotions in math class? And in that interaction with those kiddos, one student rose her hand and said, oh, math makes me feel happy. And all the other kids said, yeah, well, of course it makes you feel happy because you always get the right answer, right? So now there's this interpretation about when we have positive emotions and everything's going well in math class, we must be smart. And when we have negative emotions and things are not going as easy, then we might not be smart in math. And is that true? Is it true that the students who like math or feel good about themselves in math are the only students who are good at math? Because I would argue the opposite, because I've worked with many of those students who feel like, I'm like, Joe Cool. And I've worked with teachers too. I'm like, math is easy for me. But as soon as you dig a little deeper and give the student or the teacher an opportunity to think mathematically, not just to produce answers, but to think mathematically, sometimes the narrative shifts. And the teacher or the student might say, oh, this is really uncomfortable. Right? And then they start to doubt themselves. Then they start to think, maybe I'm not so good at math. And it's like, no. Pam Harris talks about fake math, right? Are you good at fake math? Or are you good at real math? We are all good at real math. It's just sometimes being good at real math also includes this like uncomfortable feeling, right? And it's this interpretation that we have about the uncomfortable feeling. It feels easier. I get it. It feels easier to follow the book, follow the slides. Avoid messy conversations with kids, right? If a student asks a question that you don't know how to answer, that can be very uncomfortable for a teacher. And so it's like, okay, what's the narrative? How are we going to show up? How are we going to show up for that student who is asking a question that we don't know how to answer? Do we just move on? Or do we give the student an opportunity to explore? Or do we say, hey, we're going to circle back to that? All of these things will help your students feel like they are seen. So let's disrupt their narrative. We can show students by how we teach math that struggle is a natural and necessary part of learning math. I mean, it's in the standards, right? It's in the standards that we need to persevere, right? Well, perseverance requires a bit of struggle. Perseverance requires us to work through situations that we might not feel great about, right? And how do we do that? So here's how. This is not going to be popular, but we need to slow it down a little bit. Not all the time, but slow it down and go a little deeper and ask questions like, how do you know? Can you convince me? Right? How do you know, circling back to 3 times 5/10, like we talked about earlier, how do you know that 3 times 5/10 is not bigger than 3? That's a question, right? That's a question that could create a lot of deep conversation. Why does 3 times 5/10 equal more than 1, but less than 3? Right? How do you know? Can you convince me? And in that, having students just say, well, you multiply 3 times 5 and then swoop the decimal point over one way is not going to hold up in court. How does that convince me then, right? Because that's just telling me a rule. That rule could be a completely false rule. But if I see a picture or if I see another convincing way to show me that 3 times 5/10 is 1 and 5/10, then now you've got me convinced. And in that, more importantly, the student has agency, and they have agency to choose how they're going to explain it, and they develop this autonomy that they can come up with the answer and they can explain it to you, which then means that later on, when they're asked or faced with another difficult problem or difficult situation, guess what's going to happen? They're going to feel like they can because they've done it once before. Anything that we do in life, anything, if we do something hard and we get ourselves through it, we know that we can do hard things again. And so it's just like in math class, right? We can do hard things. And maybe they're not hard things. Maybe they're emotionally uncomfortable things, because it is not emotionally comfortable to be grappling with an idea. So who do we need to be in order to show up for our students so that we can allow them to experience those emotionally uncomfortable feelings in a classroom, in a space where they feel safe to do so, and know that they're going to come out on the other side okay? All right, how can we do this? Well, I already said we can ask questions like, how do you know? Can you convince me? Another thing we can do is we can say less. Say less. We can say less in math class. So many times I hear teachers say, I can't get my students to talk. And I'm like, well, is there dead air? Is there dead air in your math class? Is there, like, how, because I know, I get it. It's so hard. I mean, I had those 8th graders, they were like, they would not open their mouths. They would just like stare at me until it was like a showdown. But if I gave them something worth talking about and then stopped talking myself and gave them opportunities to communicate with me in whatever way worked. It could be on a dry erase board. It could be on a piece of paper. It could be by raising their hands. It could be turn and talk. And while they're talking, I'm listening to what they have to say. So what is it? What are we doing in math class that's going to help our students feel like they can be autonomous, so that they can feel like they matter and that they can develop those problem-solving skills that we are all desperate for them to learn? Say less. So thanks so much for sticking around. That was a little tidbit for today. And if you found value in this episode or any of the episodes, I encourage you to hit subscribe and follow and all the things. Follow me on socials. I'm on Instagram, and that's where I'm most active. And then, or LinkedIn is my second most active, and bluesky is the last one. So thanks so much. Have a good day. I'm Pam Brett. Thank you so much for joining me on this episode of Blue Glasses Math. Please follow me wherever you get your podcasts and follow along on the conversation on Instagram. And remember, being a math person is all just a matter of perspective.